3, 2, 1. Good afternoon. My name is Randolph West. As you might tell from my voice, I am not from America. We're going to talk today about backups. How many folks in the room, show of hands, has had some sort of database administration experience? Don't lie, any of you in the front here. Some. I like the hand wave there. That's good. We had about maybe a third of the room, excluding all of these professional DBAs in the front row here to heckle me. Welcome. Come on in. We've just got started. You're never sorry. I'm sorry. I'm Canadian. So my name is Randolph. I am a Canadian, and I came from South Africa. So sometimes if you don't understand what I'm saying, please let me know, and then I can repeat it in a different accent. Cool? Cool. We're going to get along just fine. You've seen this slide before, except I changed it. The previous one said, please silence cell phones, but I'm modern. Please silence all mobile devices, including your watch. Kenneth, I'm watching you. See what I did there? I wouldn't be here today if it wasn't for the community. I'm sure you've seen this slide before a couple of times this week. Whoops, speaking to your mic, Randolph. There are a bunch of things for free online that you can do. There are a bunch of things that you can do for money as well, like come to this conference, but all the stuff that I did to get up to speed was reading blogs, going to SQL Saturdays, and that kind of stuff, and presenting at user groups, even attending user groups, and learning from people in my own community. And now, I'm a community leader, apparently. They gave me a user group on Thursday, Calgary. Who here is from Canada? Anybody? Oh, one person. Well, two, including me.
Does across the lake count?
Across the lake, well, it depends, because I'm in Calgary, so might be a bit far, yeah. And we've got a whole bunch of stuff online that you can refer to, so I'm not going to spend too much time on this slide. This is about me. You must have seen a ton of these as well. You'll notice one thing that's slightly different is that I've written there that I'm an actor, because it's true. I have an IMDb page, top right there. I've written some books, but mostly I enjoy acting, directing, producing, and speaking in front of audiences. Would you believe it? So welcome. Thank you for being here. It also says that my pronouns are they and them. That means I'm not a he or she, I'm a they. So that's cool. And in the bottom left, here's ways to get hold of me. I'm on LinkedIn, I am on Twitter. Please don't follow me on Twitter. I have 2,000 people who follow me on Twitter almost, and I speak a lot there, so don't do that. And I've written some books. I'm working on the second SQL Server administration inside out with William Asaf, Melody Zacharias, and a couple of other people who you may have heard of, and that is coming out before the end of the year with any luck. I'm putting this here instead of the end because I always forget to bring the slideshow back after the demos. Please rate me. If you think I suck, tell me why. If you think I rule, tell me why, so that I can keep the good stuff and lose the bad stuff. I have a disclaimer. Do you want to know what the disclaimer is? It's not the accent. I will be glossing over some advanced concepts in the room today because not everybody here is a DBA. And although I may talk about backup and restore, there's some things that I might leave out as well because it's not relevant to the session. There is a lot more to explore online and in books, buy my book, and other places. But for the interest of this conversation today, I'm going to gloss over a bunch of stuff. So there's things that I might mention on a slide that I will never talk about again. And there's a little asterisk next to things like that. So today, why do we back up databases? And then we're going to talk about the internals of database recovery, and then how to build a recovery plan. Why do we back up databases? I'm going to go to the audience. Hey, gang, why do we do backups? It's not a trick question, promise. So we don't lose stuff. I like that one. That's a very good reason.
Gdpr harder?
Kenneth in the front here said, so that we can make GDPR harder. I'm glad you brought that up because I have a slide on that. How many folks have heard, that's a good question before? A good question means I don't know. If I say it's an excellent question, it means I have a slide for that. So thank you for your excellent question. Anyone else? So we don't lose stuff? Yeah?
So when I do something dumb, I can roll it back.
When you do something silly, you can roll it back. I like that one. What else? I've got a bunch of things here, and maybe they match, maybe they don't, but I'd like to hear a couple more suggestions.
So if my development team does something silly, I can roll it back.
So Kenneth has turned it around and said, so that if the developers do something silly, then he can roll it back. That's a good answer. So let's have a look at some of these ones that I've got on my slide and see if they match up. Nobody mentioned corruption. Corruption is one of the biggest reasons to have a database backed up somewhere, because things fail. Did you know that I almost lost my job when I first started in consulting in when I deleted a bunch of stuff from a table? That's that silly thing, right? I almost lost my job, but the person who did lose their job happened 2 months later, same customer. Backups were on the same drive as the databases. Show of hands, who has lost data? If your hand didn't go up, you're lying. So corruption, we've spoken about a little bit, because things fail and people make mistakes. We've got user error, which we've had a couple of examples of. We've had malicious activity. Who in this room has heard of information security? That was a trick question, because there was a whole keynote this morning about it. There are people who are out to get your data. Now, they might steal it, or they may try and change it. Now, if they go and change the data, that's malicious activity. If they delete it, that's malicious activity. It's not cool. And you need to have some sort of monitoring system in place to be able to detect that kind of thing, but backups will help for that. So, malicious activity definitely counts, especially in today's times, dark times. I heard a cool poem today, and I'm trying to remember. It was something to do with SQL Server 2008 and it being dark times. I'll see if I remember it before the end of the session. And of course, the last one is disaster recovery. So I have an opinion here. My opinion, come on in. My opinion is that all three of the things above disaster recovery are a form of disaster recovery, right? All three of them, corruption, user error, malicious activity, are a disaster. So I like to think of it as disaster recovery is the reason we do backups. So how do we recover a database? Microsoft tells us to restore from the last known good backup. That's a loaded statement, because it says you need to be able to restore. So you need to have a backup. It needs to be known that it's good. So how do you know if it's good?
Test it.
How do we prove? That's an excellent statement, because I have a slide. How do we prove a good backup? Test your backups. That's how. Thank you, Derek. So all good data professionals, and of course that's also a loaded statement, because we are all good data professionals, those of us who have to manage any sort of database, even if you're not a DBA. So if I were to ask the folks who are not DBAs in the room, what do? You can shout it out? Automation. So you're more of a systems, DevOps type. Cool. Anyone else? Developer. There's a lot of developers in the room, I think. Yeah? BI. BI, also known as management reports if you work at a bank. Same thing. But the good thing to do is test your backups. It doesn't matter what you do. If you're looking after a database, even if it's an Access database, even if it's an Excel spreadsheet, it's still a database, and you still need to make sure that it's a good copy, so that if you need to go back to it, you're guaranteed that it's going to be good. So I've changed the title of this deck to Developing a Data Recovery Strategy, the most important part of your job. Because this isn't about backups, it's about getting the data back in the way that you hoped it went into the backup in the first place. We're going to talk about three things: Recovery Point Objective, RPO, Recovery Time Objective, RTO, and Service Level Agreement, SLA. These are a lot of three-letter acronyms that you might hear bandied about. Most of you in the room probably know what some of these are, but we're just going to cover them quickly in a way that's easy to understand, because if you're working in a business unit that isn't databases, then you may need to speak to your managers or whoever is looking after your department to explain why you need to worry about these things. So we're going to start with recovery point objective. And there it is. How much data are we prepared to lose? That seems like an unfair question to be asking people who are not business owners. Because you could stand to lose a day's worth of data, but your business managers might think that 1 minute or 1 second is the amount of data you're prepared to lose, or 0, right? How many folks have heard the line, "I don't want to lose anything"? Yeah, that is more than half of the room. The facts are, and I had a discussion with a technical editor of the last book I worked on, who happens to be in the room. What a jerk. Lewis said that, not me. I'm just quoting him. The conversation went around the fact that it might be possible to have 0 data loss, but that means you're going to be down a bunch of time. So if our PO is the recovery point objective, how much data are we prepared to lose, then our TO, the recovery time objective, is how much time do we have to recover. You may be able to recover all of your lost data, but it'll take you 4 weeks, and then your business goes out of, well, your company goes out of business. Your business goes out of company. There we go. I got it there. And then Kenneth raised this right in the beginning, GDPR, compliance regulations. It doesn't matter which country you are in. The chances are very good that you're dealing with somebody who is an EU resident. And that means you have to be in compliance with the GDPR, which stands for the General Data Protection Regulation, GDPR, which came into effect in May last year. How many folks in the room are from Europe? Ha, experts. I'm going to come and ask you questions later. Why did I bring this up? Because when you recover data that is older than, let's say, a deletion request, you're going to have to run that deletion again once you've recovered that data, or at least scrambled the data somehow. So these are all factors that you have to take into account when you're recovering data. So if we have a revision slide with a slightly different look, we have RPO, how much can we lose? RTO, how long will it take to recover? SLA, can we get it done? You may be a one-person team, and you may have a full-time job of 16 hours a day, and you may not have time to check your database backups. But there are ways, using automation and other techniques, to make sure that the testing is happening in the background all the time. I will discuss that very briefly, but I have a colleague who I work with, and one of the people in the room knows that colleague, who has a script that runs after every single backup so that you don't have to worry about that. It'll just pull all the files back and restore them for you. Very cool stuff. Automation is the way forward. And then compliance, regulations may be a factor. Any questions so far? No, cool. Moving on. Now we're going to talk about one of my favorite topics, which is internals. But Randolph, this is a level 100 session, and we're not here to learn about the internals of a database. We just want to make sure that we can back it up and restore it, right? Bad news is you need to know a little bit about the internals so that you know how to do a proper backup, because there's a whole bunch of terminology that's different between vendors. So like Microsoft will talk about one thing, and then Oracle will talk about something else, and then Access doesn't have certain things, and Excel isn't really a relational database, but people use it as one. So there's a bunch of things that you have to understand and how it compares, right? So how do we back up our databases? How many folks here work with Excel every day? That is, again, about half the room. How many folks work with Word? My sympathies. How many folks, that was almost half the room as well. How many folks work with SharePoint? It was different people, but again, half the room. SharePoint is a data repository, so it's a database. It stores files somewhere. You need to back that up, and you need to be able to restore it quickly. So how do we back up a database? Well, we can copy the database files. That stands to reason. You've got an Excel file, you copy it to a network drive, you zip it, do whatever. You can do file snapshots. So if you're talking about a SQL Server database, you might have a virtual machine that it's running on, and you'll just snapshot the image of the drive and hope for the best. How many folks here have lost data because a snapshot failed? More than 0. don't use snapshots for backups. Please. You can use database snapshots. This is a feature in certain vendors' products. In Microsoft SQL Server, you can do a snapshot of a database as well. And again, hope for the best. Please don't do that if you're using this for recovery. Snapshots have their use. It's not for backups. And then, of course, the correct answer, which is the built-in backup command, which is a SQL Server native backup. That's what it's called. Any folks in the room used a product called Commvault? Two people. Anyone else used a third-party backup software vendor? There's 2, 3 more people. Which vendors do you use as a matter of interest?
Currently or?
Yeah, currently. Redgate. Cool. Net backup. Cool. Kenneth shook his head vociferously. I like that word, vociferously, because it's not cool. The thing is, unless you're using the backup command in SQL Server, there is no way for SQL Server to guarantee that the data is backed up correctly. If you're using a third-party product, you are dependent on them. You are, in fact, dependent on a subject matter expert who knows that software. Because at 3 a.m. on a Sunday morning, because it's always at 3 a.m., you get paged, and the Commvault person is on vacation. And now you have to recover a database because something went wrong. Has anybody run into that problem? There's only one who put up their hand. I think some of you are lying by not putting up your hands.
You know who's honest.
One honest person in the room. That's cool. What is the one true backup method? Well, obviously, it's the SQL Server native backup, because otherwise we wouldn't be here, right? And I'm going to show you how to use it. The corollary, which is another cool word that I like to use, to the one true backup method is that a SQL Server native backup is only as good as its restore. We spoke about testing backups right at the beginning of the session. And that's using the restore keyword. Now, I don't want to make this sound simple, because it isn't that simple, but it's fairly straightforward. You have a backup to do the backups, and you do a restore to do the restores, right? I'm oversimplifying a little, but it is that simple, because if you're automating it and getting it all shipshape and doing it regularly, then you don't have to worry about this kind of stuff. Because with your automation stuff, your scripts and so on, you can test that everything's working correctly and get notified if a failure happens. So there's a bunch of things that you can do over and above what I'm going to show you today to make sure that you don't have to worry about exact specifics to backup commands and restore commands and testing your data. Any questions so far? Cool. Moving on. What does a data file look like in SQL Server? How many folks have seen the MDF, NDF file extensions on the hard drive and wonder what they are? I'm going to tell you.
The text files I put out there to confuse people.
I'm going to ignore that statement because it was unnecessarily irrelevant. Thank you, Kenneth. A data file, every single SQL Server database, including TempDB, including the master, including model, all of those things have a primary data file. By default, it has a file extension of MDF, which stands for master data file. But it doesn't have to have that file extension. But by default, if you're looking at SQL Server on Linux or Windows or in a Docker container on a Mac, all the data files look like this. There's going to be at least one data file, and that's going to have a whole bunch of 8 kilobyte pages inside. Now, I'm going to explain why the pages are important later, but this is something useful to know. There's an 8 kilobyte page boundary, so every single 8 kilobytes in that file are a database page. That includes data itself, the table structures, the indexes, the views, stored procedures. All of that is stored in pages. And each page is 8 kilobytes in size. Inside the page, there's a header and then the data itself, but that's not important for what we're going to talk about today. Lots of 8K data pages, all objects are stored in pages. Each page has a header, and 8 of these together, it's almost coincidental that I put 8 of them in the picture in a row, right? That's called an extent. And SQL Server uses extents for a certain type of backup, which we're going to get into. So it tries to keep 8 of them together at a time when it's copying and backing up and restoring, because it's more efficient to do a chunk of data that is 64K in size as opposed to a single 8K page, especially on modern hardware. Any questions about this slide? Awesome. So what does a transaction log look like? And this is the file that has the LDF extension by default, but it can, again, have any extension that you like. This is a little bit more complicated, and I wish I had a whiteboard here, but I don't, because I normally draw this. And the reason I like to draw it is because I start on one side of the whiteboard, and I take my pen, and I draw all the way to the other side, and then a loop, and then I come all the way back again. That wasn't me. That wasn't me. It was me. So the reason I draw a loop is because the log file is circular. So what happens if the file is circular? Why does it keep growing? Anybody? Not you. Okay, you can go.
It will be using those sections of it, and if it's not able to reuse a section because they're all in use, it will have to add sections on.
So Josh said if it cannot use a certain section, it'll have to grow to create more sections. Those sections are called virtual log files. So inside, unlike the data file, which has 8 kilobyte pages that are on a specific boundary, the virtual log files are randomly sized. There's an algorithm internally that figures out what those VLFs are called or how big they are, and it differs from version to version. But what you need to know is that there's a bunch of them in the transaction log file, and it's circular. So it'll use one, use the next one. When it runs out of them, because they're all active, then it'll need to grow the log file. How many folks have backed up a SQL Server database, a brand new SQL Server database, and suddenly the transaction log starts growing? It's going to happen, and I'll tell you why as well. So what happens is when you're inserting data, it has to write everything to the transaction log before it commits it to the master data file, because SQL works mostly in memory. So when it's doing stuff to your data, it's doing it in memory, but it's backed by the transaction log. So, in my opinion, the transaction log file is probably a little bit more important than the master data file, the MDF. Why is that important? Because you might have slow storage for your log files because it's just a log file, when in fact it should be the other way around. You need the fastest possible storage for your log files. Yeah? Any questions about that? And I'll show you how the circular nature of the transaction log file works in a few minutes. So virtual log files, VLFs, they're different sizes. Again, like the data pages, they have something at the beginning called a log sequence number, so that's kind of like a header. And that tells SQL Server where it is in the file, because if it is circular in nature, it has to keep track of where it is. So that log sequence number is used by SQL Server to figure out which parts of the transaction log file to use. You can have active and inactive VLFs, which we'll talk about a little bit more, and it's circular. Oh, I always forget about this. No, I don't. What is a recovery model? None of you in the front row. I'm too scared to turn off the screen. Yes?
Basically the amount of log data that it keeps as it commits transactions.
I'm going to quote you and say it's basically the amount of data that it commits as it's working with the data, correct? Correct?
So basically, depending on what mode it is, that's how much it stores.
So you're saying that based on what mode it is, that's the amount of data it stores. So I'm going to be unfair and say it's not a mode, it's a model. And that's a common thing that people do. So don't be offended by me correcting you. It's a recovery model, not a recovery mode. I used to do the same thing, so don't worry about it. But yes, you are correct. So depending on the recovery model, it depends how much of the transaction log it retains until you do a transaction log backup. So remember I asked how many of you have dealt with backing up a database and suddenly the transaction log grows? It's because the database is in the full recovery model and nobody's done a transaction log backup. So we're going to talk about managing full backups, transaction log backups, and differential backups. Show of hands, who's heard of full database backups? Cool, almost the entire room. Who's heard of differential backups? Almost the entire room. Who's heard of transaction log backups? Almost the same people again. Good stuff. What is an incremental backup? What's that? You are incorrect. It is not a differential backup. A transaction log backup is an incremental backup, but a differential backup is not, and I will show you why. Thank you for volunteering to give that information, and thank you for helping me correct it. The full recovery model is the one that gives you the ability to do a point-in-time restore. We're going to talk about that. The bulk logged recovery model, is there anybody in the room who has heard of that? Of those people, who's used it? Lewis, seeing as you put up your hand for using it, why have you used the bulk logged recovery model? You don't remember. Was it a long time ago?
It's been a while, yeah.
So
It lets you do both operations.
it lets you do bulk log operations, which I'll show you. But it's kind of weird, and I don't like it because it's not what you think it does. And I would prefer, if you want point-in-time restores, to do full recovery model. And if you don't want that, then just use the simple recovery model, which is the next one. There's only 3, and most of the time, people use the full recovery model and the simple recovery model. Bulk logged, I don't know many people who are using it today. Any questions so far? Good. Full recovery model. Every transaction is fully logged. So if you go and run a delete statement against the table, it's going to log every single row that you've deleted, every single one. If you delete 10 million rows, it's going to have roughly 10 million entries in your transaction log. So that's going to blow out the transaction log quite a lot, wouldn't you say? So there are such things as long-running transactions that can cause the transaction log to grow, because remember we spoke about VLFs. If it runs out of space in one VLF, it's going to go to the next one, to the next one, to the next one, to write all of the changes to the database as it's happening. Only when it has finished writing those will it commit the transaction in the master data file. Remember that? So your transaction log needs a lot of disk space for long-running transactions, and there is a chance that you can run out of disk space. That's bad. So you need to manage your full recovery model backups correctly. So the log file grows until it's cleared. You need log backups, regular log backups, so that you can manage the size of the transaction log file. And it allows point-in-time recovery. These are the 4 reasons that I use full recovery model, but there are some customers of mine who use BI systems that don't need to be transactionally logged, and they have something called the simple recovery model, which we'll talk about, which just needs a daily full backup, for example. It doesn't need a point-in-time restore if something were to go wrong, because you can just reload that data from your source system. Any questions about full recovery? Moving on. The bulk logged recovery model uses minimal logging for certain operations, including bulk insert, create index, and select into. Now, you might be using these operations in your environment, and you might find that if you're loading millions of rows into a table, that you're generating a lot of transaction log, and you'd like to reduce that. Bearing in mind that if you don't keep your transaction log backups up to date, that this might not be able to offer you a point-in-time restore. You might only be able to restore up to the point before your bulk logged operation. Any questions about that statement? Because it might be confusing. We're good?
Is that based on the transaction log backup or the full backup?
It's, what is going on here? The point in time is based on the transaction log backup. So Lewis asked, does that point in time restore depend on the database backup, the full backup, or the transaction log backup? It depends on a point in time according to when a transaction occurred, and because that's written to a transaction log, you would use the transaction log to help you find that point in time and restore up to then. Does that answer your question? Yes, Kenneth?
So, am I remembering correctly that best practice is to go, you stay in full recovery normally. If you need to do a bulk operation, you switch to bulk recovery, and then you switch back again?
Kenneth has asked if it's a best practice, and this is a loaded question because best practice can change and it can depend on your environment. So I'm just going to hedge with that. Okay. Asking if it's a best practice to keep your database in full recovery model, and then when you do a bulk logged operation, to switch the database to bulk logged, do the operation, and then switch back to full. If you're trying to reduce the amount of transaction logs that are generated, that might be favorable for you in your environment. But what is the difference then between that and just doing more regular transaction log backups? That would be my question to you. And again, it depends on the environment. Yes, Derek?
Yeah, so I was just going to add is there's been times where I've either switched to simple or just sped up how often you're doing transaction log backups for that task.
So Derek's suggestion is instead of using bulk logged, he would use simple recovery model instead.
If I remember correctly, though, switching to bulk log does not break the recovery chain.
It doesn't?
Simple does.
Correct. So we'll talk about the backup recovery chain. That is an excellent statement, because I have a slide for that.
But it's if the transaction log has bulk log operations, you can't do point in time. The next one you can do point in time.
Correct. So Lewis has said that if the bulk logged database has, say that again?
If the transaction log backup has a bulk logged operation in it,
If the transaction log backup has a bulk logged operation in it, it's not actually backing up a log, it's backing up the data that changed. So that's why you can't do a point-in-time restore, because it wouldn't know how to sort through that data. It would have to go to a point before or a point after. Yeah? So the log file grows until cleared. This is just like a full recovery model. And log backups are necessary, just like the full recovery model. And you can have some point in time. And of course, emphasize that because for the very reason that Lewis brought it up. It's almost as though you were a plant, but I can assure everybody that Lewis isn't here as a plant. I paid somebody else, but he's not here. It's not a fern either. Simple recovery model is the one that a lot of folks tend to use because you can use simple recovery in combination with differential backups, and you can have, not quite point in time, but you can have a reduced number of backup files for good enough, right? Who didn't silence their mobile device? Fired. So the simple recovery model is for folks who don't need point-in-time recovery. That would be like reporting-style databases. So if you've got a BI environment that you can reload from the source system every night or every week or whatever the case may be, sure, you may take a little bit of pain if you have to reload that system from scratch, but it's available and you can do that. Then a simple recovery model may be for you. Or in fact, no backup. It's up to you, right? But for a business-critical system, simple may not be appropriate. And that's because you cannot do a point-in-time recovery. Yes?
When I use this in a system where maybe I have a real specialized investment accounting system, and I have a real small number of users, and so would that work where you have the ability to just go to that internal user?
I'm going to rephrase your question and ask it in my own way. And I'm going to say, are you asking whether it's okay for smaller databases that don't have a lot of, it's not me, I promise. Smaller systems that don't have a lot of users, so not a lot of transactions are going through the system. Does it make a difference if you switch to simple or if you keep on full? But the statement I'm going to say to you is that the transaction log doesn't grow unless there are transactions happening. So if you do a transaction log backup every 15 minutes and nothing's happening in the database, your transaction log backups are going to be very small. So if you want a point-in-time recovery, use full recovery model. If you don't, and you think a daily backup is good enough, then do that.
oh, sure.
And it depends on the business. Yes?
So when you take the transaction log backup, and does it transaction log file shrunk automatically?
Excellent question. So the question was, when you do a transaction log backup, does it shrink the transaction log file size? And the answer is, no, it doesn't. However, the documentation and previous books and everybody talks about log truncation. So although we use the term truncate, it doesn't change the file size. I swear that's not me. I didn't even do anything there. Something's janky with this HD here, with this HDMI. It's fine. So a simple recovery model, if I don't move, it's going to be fun during the demos, but let's see what happens. The simple recovery model has no transaction logging at all. In other words, you don't have to worry about transaction log backups. But as I mentioned briefly earlier, you can do differential backups, and I'm going to show you that. So if you want to have a full backup every week, let's say, and then you want to have a daily or nightly backup that isn't as big as the full backup, you can do a differential backup. And now here's the thing about differential backups, which we'll get to, is it's not incremental. So every new differential backup that you do is larger than the previous one because all you need to get back is your full backup and the latest differential. That's why it's not an incremental backup. Transaction log backups, if you want to restore to a point in time, you need to restore all the transactions up to that point. So that's why transaction log backups are incremental. Does that answer your question from earlier? Cool. Yes?
Second question about the transaction log. I had a really weird experience that I took so someone told me that the 170 gig wrote the transaction log file. So then I took a backup of the transaction log, tried to shrink the log file. It didn't. And then I just left the office and then came back, next day, and it shrunk to 1 meg.
There's a lot to unpack from what you said there, and all of those things you said are accurate. So to recap, there was a 170 gigabyte transaction log file because something blew out the transaction log. That happens all the time. It could be something a small transaction that was running in the morning, and then it never completed because somebody forgot to press something or type commit in their SQL Server Management Studio window. And then everything else that people were doing on that database just grew the log file because it just couldn't clear what was happening there because it wasn't committed. So you grew 170 gigabytes of transaction log file. Then you decided to take a backup of the transaction log so that you could try and shrink the log file. Okay, I'm going to take a sidebar here because it's not quite finished with what you said. There's something additional to that, which I'll get to. Show of hands, what is the worst feature in SQL Server? Is it auto close or auto shrink? Auto close, raise your hands. That means that the database will close when the last person has finished writing what they're doing, so every time you connect, it has to put it back into memory again. That's pretty terrible, wouldn't you say? Who thinks that's bad? That's bad. How about auto shrink, which means that every few minutes it says, I need some more space, so it's just going to shrink the database, cause a whole bunch of fragmentation, and just make everything slow. A lot more hands went up when I said auto shrink. Why did I mention auto shrink? It's because database shrinking and transaction log shrinking are not the same thing. Ooh. If you shrink a database file, it causes fragmentation, because remember, it's on those 8 kilobyte page boundaries. So what's going to happen is all the 8 kilobyte pages at the end of the file are going to be moved to the beginning, and it works backwards. So it's going to cause almost perfect fragmentation, which is not what you want. So all the pages at the end of the data file, if you shrink the data file, are going to be pushed to the beginning wherever it can find a gap, and then when it's filled everything in, then it drops the end of the file off. That's how it shrinks a database. Shrinking a database is bad. Turning on auto shrink is even worse. There are some scenarios where shrinking a database file is necessary. Then you get the scenario where you can shrink a transaction log file. If your transaction log blows up by 170 gigs and it's not usual, and you usually get 10 gigs or 20 gigs in any sort of business period, then shrinking a transaction log file is part of your maintenance plan. There's nothing wrong with that. So what the gentleman said is that he created the backup, the transaction log backup of the 170 gigs, and then tried to shrink the log file, but it didn't shrink. I know why, and most of the people in the front row know why. Anybody else want to guess why it was unable to shrink until the next morning?
I'm not a DBA, but I'm going to venture a guess the transaction didn't finish.
Your suggestion was that the transaction wasn't finished. That is not the correct answer, but it's a good guess.
At the time I searched Google and it says that active transaction is end of the file.
Correct. That is the correct answer. You searched Google and it said that it's because the active VLF was at the end of the file. So because the active VLF was at the end of the file, it couldn't shrink it because that part of the file was in use. Remember the circular nature of the transaction log? So what that means is the active portion had to move to somewhere near the beginning of the file before it could shrink. Now, because you'd done a full transaction log backup and because nobody had done anything else in the database, when you shrank it, it went all the way down to 1 megabyte, which is the default. And then you probably, It is if you do certain things. Yes, it is. And don't argue with me. Remember that disclaimer slide. So you would then have had to either regrow that file again to its regular size or wait for it to auto-grow. Which one of those two things did you do? Do you remember? Did you just leave it and... Okay. Care and feeding of transaction log files, which is not really part of the session, says that you should grow it out to its regular size so that you don't have to wait for the file to grow whenever a transaction gets too big. But we'll talk about that after this.
So is there, at that time, is there any way to kill the active, I mean, circular back to the front beginning of the file?
Is there any way to kill whatever was active at the end so that it can go to the beginning? Is that your question?
Yeah.
SQL Server 2019, yes. Something called accelerated database recovery, yes, because that stops using your transaction log for a bunch of stuff. Yeah. So simple recovery model, coming back to this, there's no point-in-time recovery possible because you don't have a transaction log backup. Cool? Cool. We've done the three. Let's revise what we've learned. There are full backups, differential backups, which we spoke about, transaction log backups, which we spoke about, and then there's other kinds. This is the stuff I'm going to gloss over. I'm skipping this. File or file group backup and partial backups. They're enterprise edition only features and not really in the scope of this conversation to learn about backups, right? How many folks in the room have actually done a SQL Server backup? Awesome. That is almost the full room. A full backup using the backup database command in T-SQL copies the entire data file and the active portion of the log. Why do you suppose it needs the active portion of the log? Because the data file may not have everything in it, because remember at the beginning I said SQL does everything in memory and then is backed by the transaction log file. So you need that portion of the transaction log file to recreate a transactionally consistent database when you restore it. So all those active VLFs, when you do a full backup, are copied to the end of the backup file. Yeah? So I'm just going to go back. Yes, Lewis?
It's consistent to the, when it completes.
Lewis is asking, does that apply to when the backup started or when the backup ended? And the answer to that is yes. It's actually to the end. So when you do a backup of your database, a full backup, any transactions that were in progress when the database backup ends will have to be rolled back. But anything that completed when the backups, between the time the backup started and the backup ended, any ones that completed in that time will be included in the transaction log, the active portion at the end. It's a good question, Lewis. Thank you. I wrote here, and I'm going back to the slide again, full backups apply to full bulk logged and simple. I mean, that makes sense, right? Oh, I like this one because there's developers in the room. You may be asked by a colleague for a full backup because they need to do something with their copy of the database. Yeah? How many people have been asked by a colleague for a full backup of the database so they can do stuff? It's not an uncommon scenario. The problem is, if you have differential backups, then this breaks things unless you use the copy-only feature. So let me explain how this works. Again, just like the full backup that we saw before, it does a copy of the entire data file. It copies the active portion of the log. It does not affect differentials. So what that means is there's a portion of the database file called the differential bitmap. I didn't do that, I promise. It keeps cutting out. Wasn't me. So the differential bitmap doesn't get changed. So that means if you're doing differential backups that are based on the full backup, then those are not affected by a copy-only backup. So if your colleague needs a copy of the database, give them a copy-only version. Gasp. We're going to go straight in. That's okay, I'll go on. So while we have some technical difficulties, I'm going to talk about differential backups. Now, differential backups, as we established, are not incremental. So what happens is you have a full database backup that you need as your starting point. This is part of what we call the backup chain, the transaction log backup chain. So just like a chain with links, you need a starting point, and then from that starting point, you can build a history if you need to restore to a point in time. And that backup chain requires a full backup. A differential backup is used to bypass hundreds, thousands, tens of thousands, or even hundreds of thousands of transaction log files that you might have, because it's possible. And so you will have a differential backup that is a shortcut that bypasses a whole bunch of those files so that you just need a full backup, the latest differential backup, and whatever transaction log backups came after that differential backup. So a differential backup looks at your database. Remember I spoke about something called the differential bitmap? The extents that I mentioned, the 8 pages, the 64K line that I showed you in that first image, that's an extent. And the differential bitmap keeps a copy of which extents in the database changed since the full backup. And then all that a differential one does is it goes and grabs those pages off the disk. It grabs those 64K blocks or extents, shoves them into a differential backup file, and then has the active portion of the log at the end to make it transactionally consistent. So again, a differential backup is a shortcut. It can be used alongside transaction log backups. They don't replace each other. They're used complementary to each other. So I'll show you, if we have time for the demos, to go how they all interweave together. So if you've got a full transaction log backup and you have a whole bunch of, if you've got a full database backup and a whole bunch of transaction log backups, that's okay. But if you want to bypass that, let's say you have a full backup every month or every week, you can have a differential backup more frequently, and that will help you shortcut your restore process. Differential backups are not affected by copy only, so if you want to give a copy of your full database backup to a colleague, then you would use the copy only command. And differential backups work on full, bulk logged, and simple. So let's talk about transaction log backups. Remember I mentioned that every single backup type that we've seen for the database side uses the data and the active portion of the log. What this does is it's just the active portion of the log. It doesn't need to keep a copy of all the other stuff that is not active. Why should it? So it just keeps an active copy. So if you have a long-running transaction, all the active VLFs will be copied to the transaction log backup file. And if you do that regularly enough, some folks do 5 minutes, some do 15, some do 4 hours, whatever the case may be, it doesn't matter how frequently you do it. If you add up that time, it's still going to add up to all the transactions that have taken place since the last transaction log backup. And now we're going to talk about the backup chain. See, this is why I said it was an excellent question. This is not easy to see, but it's easy to understand. On the left is your full backup. The black square with full backup written in there on the left. Then at the bottom row, we have transaction log backups that happen at a regular interval. Then on the top row, in a separate lane, imagine there's 2 lanes on the highway, the second row, the differential backups are on top, and that is a shortcut for your backup chain. Any questions about the backup chain? I'll just add this. Log backups are incremental, differential backups are not. So we're here to learn about doing recovery plans. So to recover from a database failure, whether it's corruption or malicious intent or somebody forgetting a where clause in their statement, you need to restore the full backup first, because remember we've got the backup chain here, so you need the full backup to start. And you can use a copy-only backup as your full backup start. Who knew that? One person in the room. It's pretty cool. You can use a copy-only backup in certain circumstances to restore your database. For a point-in-time restore, this is a very basic method, so this is for people who are just starting out and want to practice with a point-in-time restore. You will have your full backup, and then you will restore all your transaction log backups. But because your full backup is a separate file to your transaction log backup files, you need to use a parameter called with no recovery after you do each file so that SQL knows not to run recovery on that file and on that database until it's finished. So what you're saying is, with no recovery on your full backup recovery, full backup restore, you need to have the with no recovery so that you can apply multiple transaction log updates after that. Then when you're done, you tell SQL, restore with recovery, and then it just brings the database live and everybody can use it again. To do a point in time with differential backups, remember differentials are for a shortcut. You would have your full backup. Why do you suppose I got a little asterisk there? Cannot use a copy-only version of the database with differential backups. Correct. One person has learned a valuable lesson today, and that is me. So you need the full backup that is not a copy-only backup, so it's a regular backup in other words. You need to restore the latest differential backup. If you don't have that, then you can just restore all transaction logs, and again, you would use the with no recovery option. Where's my automation guy? Yeah, automation is the new black, or pink. I like pink. Automate your backups. Has anybody here heard of Ola Hellengren? Do you know that he's here this week? He wrote one of the best maintenance solution tasks that a bunch of people use, and it's free, free, free. Has anybody heard of Minionware? Jen and Sean are here as well. Did you go and see them at the booth? They've written their own version of a backup management tool. They have a paid version and a free version. The free version works just fine. Have you heard of DBA tools? Chrissy's not here this week, but Rob Sewell is here, and Rob Sewell is one of the creators of DBA tools. These are free products that you can use to manage your database environment for you so that you don't have to manually type a backup script and set up a time to run it every 15 minutes or whatever the case may be. When you're automating, and the automation experts in the room will tell you this, don't tell me when it worked, tell me when it failed. Because you don't want an inbox full of emails saying, everything's okay. Because eventually you stop caring, and then you file it all away using a filter, and then when there is one problem, you never see it. So always notify on failure, not success. And you need to automate your restore script. So whenever a transaction log backup happens, Derek and my friend Steve Stedman has a script that runs at the end that generates a T-SQL file. It's just a text file that SQL Server can run, which takes the file name, the path, and just creates the script for you. So it's free as well. It's very easy to use. Yes, Kenneth?
I believe both Olas and Minionware do the same thing.
Correct. My point is, Kenneth said that he believes that Olas and Minionwares does the same thing. They all do the same thing. I'm pointing out that there are tools out there so that you don't have to do your own. So yes, that is a good statement to make. So they all do this for you. You don't have to think about it. You test it, obviously, make sure that it all works, and then just let it run. And then once a week, if you're so inclined, check that your backups are running somewhere. So now we're going to talk a little bit about best practices. What's a best practice? Well, it depends. I say it depends because there's some things in here that some people don't want to use because it takes too long. So let's talk about the first one. You can use backup database, the command backup database, with the checksum option. And what that does is it goes and makes sure that every single page that is writing to the backup file matches the checksum for the entire database file. It's not technically correct of what it's doing, but I am glossing over the details. I can see your face. But a checksum makes sure that the file that you have on disk and all the pages inside it, when you can restore with that same checksum and make sure that everything's cool, so that you can validate the backup file without having to restore the backup file. It's not perfect, because the best way to prove that a backup is working is to restore it. But it is a data point to say that things should be okay. The second one should actually be higher up on the list, especially after today's keynote. You should make sure that your backups are off-site in a secure location. Now, obviously, we can't have a world where you don't have data. So where we do have data, we need to have those backed up in a safe off-site location. How many folks in the room, regarding my story earlier, how many folks in the room have their backups on the same machine as their database? And of those people who put up their hand, how many are not copying those files somewhere safe? Don't do that. Because it's okay if you have your backups running to that machine as long as you get them off there as soon as possible after the backup is complete, right? Who here has heard of DBCC checkDB? Good. That was about half the room as well. CheckDB, check database. It is a function built into SQL Server that will go and check every single page, every single relationship, all sorts of cool stuff under the covers, indexes, tables, views, you name it, to make sure that the database is consistent. You should do this every time you do a restore, because you could restore a file that might have corruption in it. You may have backed up that corruption without realizing it. The disk that you're copying to may have flipped a couple of bits while it was writing. You need to make sure that everything that you do is valid, and the best way to do that is to restore the database and check it for corruption using CheckDB. CheckDB is slow on large databases, so there are some flags that you can use to modify, to only check physical properties and things like that, but this is something you should do. Yes, Derek?
I'd like to throw another best practice on there. Check that you don't have a third-party backup tool ruining your...
Derek's just raised an interesting point. Check that you don't have a third-party tool ruining your log backup chain. For example, let's say that you're doing regular full backups once a week, and then you do a differential backup, but you don't know that Commvault, and I'm not, or any vendor for that matter, is doing another full backup halfway during the week. And so when you come to restore your database and you try and use that differential backup, it's going to be based on the first one and not the one that the third-party vendor used, and it's not going to work. So then you're going to have to go back to your transaction logs. And you better hope that your transaction logs are not corrupt. So it's a very good point. Thank you for raising that. And automate all the things. Use DBA tools, use PowerShell. These are things that most folks in the room here have used in some way or another, and you can apply it to database backups. And as we've seen, there's some tools out there that do all of this stuff for you. Tips and tricks. Don't use SQL Server Maintenance Wizard. Hands up, who's used SQL Server Maintenance Wizard? Stop doing that. Okay, I'll explain why. The Maintenance Wizard is legacy. That's the nicest thing I can say about it. In other words, it was designed at a time when we didn't care that much about efficiency of processes. So there are maintenance tasks that run inside the Maintenance Wizard that may not work the way we expect them to. So what you want to do is have full control over your process and use things like Ola Hallengren, Minionware, DBA tools, that kind of thing. In fact, DBA tools uses Ola Hallengren's maintenance solution under the covers. So you might as well just use it anyway. And because it's Thursday and there's still a whole day tomorrow, you can go and find Ola and thank him. I do regularly, especially when I have to do a restore. Oh, look at that, demo time. Do we have time? What time do we have to finish, 6? 17 minutes, we should be able to do that. Any questions so far? We good? Cool. Let's see if I break the screen again. Has anybody used a Mac?
What's a Mac?
Apple computer. Have you ever used one? I'm using one right now. This is a Mac. And down at the bottom here, we have Azure Data Studio. How many folks in the room have heard of Azure Data Studio? Almost everyone. That's good. For those of you who haven't, don't get misled by the name Azure in Azure Data Studio. It used to be called SQL Operations Studio. I think that's more appropriate, but the shortcut was SOS, and that was, yeah. Don't do that either. So how does Randolph get SQL Server running on a Mac? I've heard a couple of answers. The correct answer is containers. Has anybody heard of Docker? Raise your hands if you've heard of Docker. Yes! Definitely more than half the room. Docker is a virtualization environment that allows you to spin up different things like SQL Server databases, like applications, like web servers. And when you don't want them anymore, you just throw it away. You don't have to reinstall the operating system. And my favorite feature is that it's cross-platform. So I'm using a Mac here, and I can run SQL Server 2019 RTM GDR, yep, which came out, what, Monday morning? Took me 2 minutes to download, 2 minutes to install. Don't believe me? I'm going to blow away the container. I need to type in my password, which is going to take longer than blowing away the container. And it's done. So, what do we have here? How many folks in the room have used Azure Data Studio and use it regularly? It's going to be a small number. I figured as much. Don't think that Management Studio is going away. It isn't. These can be used together. And on Windows, you should use them together. There's some stuff that you can use in Azure Data Studio that you can't do in Management Studio. And if you're using the latest versions of both tools, you can actually run menus that pop up different things between the two applications. It's very cool. I would highly recommend it. So what I've done here is I've got a database backup test example 1. I've done a select add version, which tells me this is SQL Server 2019. And then it says, hey, yes, you, have you turned on backup compression at the server level? Show of hands who knew that you could back up databases compressed. Did you know that you can compress your database backups natively inside SQL Server? Do you know why that's cool? Because you use less disk space. Why is that cool? Because it means backups and restores are quicker because it doesn't have to go to disk, because disk is the slowest part of your computer. Yeah? So, turn on compression by default, and we can do that a number of ways. Because we don't have Management Studio, I can't right-click on the instance, so I'm just going to run a script instead. And the script says, backup compression default, which is a configuration option, is set to 0. Can you all see that at the back? Cool. So all I'm going to do here is run the configure command to turn on backup compression. Trust me, because I'm about to create 1 million rows in my database. So the first thing I'm going to do is create a database. Anybody here heard of the drop if exists command? That came with 2016. Very cool. So I'm going to create a database called backup test example 1, and I'm going to turn on accelerated database recovery. It's not on by default, but this is going to make your restores faster overall. There are certain circumstances where it doesn't, but this is not the room for that, so look it up. But if you're running 2019, turn this on, and you'll thank me later. So I'm going to enable accelerated database recovery, and then I'm going to use the database, and I'm going to create a table called table test, because I'm extremely original in my examples. I'm creating a single column. It is of a type unique identifier, so it's a GUID. What do we know about GUIDs? They're unique. What happens if I insert 1 million rows into that unique table? Well, 1 million unique rows into that table. It's going to fragment the heck out of it. It's going to be randomly inserted, so it's going to be a lot of pages, which is what we want for a backup. Cool. It's an easy way to do it. And the other cool thing is I'm going to insert 1 million rows into this table in 4 seconds. Do you believe me? 4 seconds? 3 seconds. Sorry, I lied. I just inserted 1 million rows into the table, and to prove it, I'm just going to do a select count, which is going to show me there's 1 million rows, and this is the top 10. So it's just random GUIDs. Yeah? Doesn't need to be fancy, because all we're showing here is backup and restore. We're not showing you data types. Don't use GUIDs for a primary key, please. So because I'm using Docker, Docker is based on Ubuntu Linux. Who here has heard of Ubuntu Linux? Who here says Ubuntu? You're wrong. I'm from South Africa, so is Mark Shuttleworth. Ubuntu is a word that comes from a local language, one of the 11 local languages in South Africa. It's not Ubuntu. Please stop saying that. Thank you. If you learn nothing else, it's that. But what I wanted to show you is that because we're using Linux in the background in a Docker container, there's no C drive. If you want to join my session tomorrow at 2 o'clock about managing and monitoring SQL Server on Linux from the command line, we'll do a whole bunch more of this. But for this case, it's using a Linux file path. And I'm just going to run this. And there's my backup that ran in 457 milliseconds. Yay. Now I'm going to do a backup of the log. Why do I care about the transaction log backup? Because the answer is, by default, every single database you create on SQL Server, by default, is in the full recovery model. Did you know that? You do now. And if you did know that, cool. So we're going to do the transaction log backup. Did it work? Yes, it did. And it took 457 milliseconds. Now I'm going to insert another million rows. So remember where we are now. We've got our database. It's got 1 million rows in it. We've done a backup of the full database backup, and we've done a transaction log backup. Cool? Nothing changed between the full backup and the transaction log, but we wanted to clear the log. So that's why I did that. Now I'm going to insert another million rows into the table. Now this takes a little bit longer because it has to grow the file, so it'll take closer to 5 seconds than 4 seconds. There we go, 4.7. And then I'm going to do another log backup. So I'm backing up the new million rows that were just done. 700 milliseconds. Now, remember that I said you can run transaction log backups alongside differentials. So that's what we're going to do here. We're going to do a differential backup, which is based on the full backup that first happened. So this is a shortcut so that we don't have to restore 2 transaction log files. We can just restore the differential, and we'll be at roughly the same place. I say roughly because I'm the only person using this database. It'll be the same place, but if other people are using the database, other things may have happened in the meantime. So the differential backup took place. There it is. And now I'm going to insert another million rows. So we should be up to 3 million by the end of this. And this takes about 5 seconds as well. And now I'm going to take a transaction log backup to finish the last 3, so that we've backed up all 3 million rows in some way or form. Now I'm going to switch back to the master database so that I can drop this database, because I'm simulating a disaster. Something happened to the hard drive, it's gone. So there it goes. 123 milliseconds, 3 million rows, gone, gone, gone. Yay. Or you could pay me lots of money per hour to fix that. So what I'm doing here is just restoring the full backup that I took originally. Now, let's say that I forgot to use the with no recovery. Can I apply a transaction log backup after I've done the full recovery? The answer is no, so this is going to fail. The log or differential backup cannot be restored because no files are ready to roll forward. That's the error message you get. It means you forgot the no recovery option. But we're still going to have a look and see what it looks like. We're expecting 1 million rows. And sure enough, there are 1 million rows. That's from the full backup that we first took. So now I'm going to drop that database again and restore, but using the with no recovery option, so that I can apply transaction log backups to that full backup and get to the 3 million as we did before. Now I'm going to prove that transaction log backups are incremental. So I'm going to take the first backup that I had, the 1 million rows, and then I'm going to apply the last transaction log backup, the third one, and it's going to fail. And it's going to say the log sequence number, the LSN, is too recent to apply to this database. It's looking for a log sequence number that came before this one. So you need to go and find that transaction log backup that contained that log sequence number, or a differential backup that might shortcut that whole business. So we're going to do a restore of all 3 transaction log backups. Now technically, remember I said that the first backup and the first transaction log backup, nothing changed in between. So I probably don't need the first transaction log backup there. But if something happened, somebody else did a change, it's good to have it. So I'm going to do all 3 anyway. And notice each command has the with no recovery option. So I'm just going to scroll a little bit here. And in fact, yep, it's all happy. So now I'm going to restore the database with recovery. That's the only thing I'm doing. I'm not putting in a file name or anything like that. I'm just saying, database is ready to go now. All 3 million rows have been restored. Let's see what happens. So I'm going to run that. And that took 400 milliseconds, and everything's cool. If we do a select from here, we should see 3 million rows. And we do. That is as easy as it is to do a restore. Any questions so far?
Question. So the third one, the third transaction log file, when you not specify in no recovery, then automatically recover?
So the third one I did with no recovery there, line 155, but then I did a restore database at line 159 with no file name that just says, I'm not providing a file, but I want you to bring the database back into active mode so that other people can use it. And then behind the scenes, it's going to roll forward a whole bunch of stuff. And with accelerated database recovery, it's really, really fast to do that. That's why it looks almost instant. So now I'm going to drop the database again and demonstrate the differential restore. So first I'm going to do the full backup. Then I'm going to do the differential backup that we took. And there it's done. And that wasn't me again. There it is. So now, because I've done the differential backup, and now I go back to the first transaction log file, it's going to fail. And so will the second one, because the log sequence number in those transaction logs are earlier than the last one in the differential, because the differential is a shortcut. So we should see an error message there, and we do. And then we're going to see a restore database from number 3 only. And there it is. So again, I'm going to do that recovery option without any file name there, just to bring it into use for everyone. And we should see 3 million rows again. There it is. Cool. We have 3 minutes. Do you want me to show you the copy-only demo, or do you just want to get out of here because it's 6 o'clock? Your call.
Would you be offended?
I would not be offended because I want to get out of here as well. But what I did want to tell you before you go is that these scripts are available on GitHub. How many folks here have used GitHub? Good. Good crowd. If you haven't used GitHub, you can still access these files without having an account. You don't need an account to get them. So you'd go to github.com, and then because my company is called Born SQL, you'll see Born SQL there in the URL, and presentations. And then there's a backups presentation, which is the one that we're doing here, and you can see the scripts there if you want. And finally, please submit your evaluations, not just for me, but for every speaker you've heard this week, because it helps us be better speakers. So thank you very much for coming. I appreciate your time.